afternoon. I've been in the Dean's office for 25 years, so that means I introduced a lot of people over the years at conferences, events, but today is a special one because he was my roommate 32 years ago. Very pleased to have you all here. President Cohen, our guest today, one of our distinguished alumni. Marc has been the Executive Vice President, some of this I have to read, Executive Vice President for Operations for Selectron Corporation, which is a publicly traded contract manufacturer which produces and assembles circuit boards and other electronic components, somewhere in California. Prior to Selectron, Marc was Vice President and Manager in charge of supply chain for GE Medical Systems. By the way, he told me at the time that he gets a phone call from Jack Welch. He says, "Marc, I have good news for you. You're now on the board." And he says, "You can celebrate that for 5 seconds. Bad news is we have a meeting this weekend." Jack Welch. Marc, as many of you know, has established a fellowship fund here at the school, which supports a European MBA student. He was born in Paris. You can tell from his accent, of course. He has a degree in economics and engineering at the University of Lyon and l'École Centrale de Lyon, and 75 Master of Science Industrial Administration here from the then GSIA. Marc and Sally, his wife, have 2 adult children, Corinne and Philippe, and we're delighted that he's here to talk to us today, my roommate.
Thank you, Ilka. I promised Ilka that I was not going to tell you anything about Ilka at the time, because I understand there are some students around here. But during the beer time, you come and ask me, okay, guys? Thank you, Ilka. I would like to speak to you today about what's my life right now, and share with you why operations excellence can make a tremendous difference for a company. So this is not a very fashionable talk, because if I believe fashion, us in the Western world, we're supposed to do only finance, marketing, and all this very intellectual stuff, and doing things on the shop floor is not very fashionable anymore. Well, I'm going to try to make it fashionable for you and share what I'm doing with you about transforming a company, and even I'll be immodest enough to think transforming a whole industry with operational excellence, and operational excellence built on 2 foundations of excellence, which are Lean and Six Sigma. And I'm going to go a little more in detail on this. So let me speak to you about an industry that is so popular, so glamorous, so fantastic. The electronic industry. It's a great place. It is, of course, in all the industries right now, the industry with the fastest innovation. Every 6 months, there is a new product, which as a customer, I find extremely exciting. As a father, I find a bit expensive sometimes. But certainly as an engineer, I love and admire. And so, you know, a new product launch every 6 months. Engineers keep on inventing new stuff. Marketers sell it before it's totally invented. It's a great industry. It's a great industry who has a major Achilles heel, and it's called the supply chain. Of course, most of the electronic industry leaders dream of only one thing, is do software only. The advantage of software, you don't have too much to worry about supply chain. The problem is that software usually runs in a box, a hardware. So in that case, somebody is going to make the stuff. And that is the Achilles heel of our industry. You see, our supply chain in the electronic industry is a very mediocre supply chain. It's very slow and it's mediocre quality. But it's very slow. It takes 6 months to do anything if I take the time between silicon and a product. So let me just summarize that again. 6 months, a new product. And I guess that means, mathematically, that because the supply chain takes 6 months, that by the time the manufacturing guy arrives and tells the customer, Mr. Customer, here's your phone, the customer says, beg your pardon, that's the previous model. I want the new one, the one you're advertising. And the manufacturing guy said, oh, okay, well, you have to wait 6 months, right? So that's what began in the beginning of the 80s when the PC was invented and all that stuff. I know for some of you young people that's like antiquity, but for me, I graduated in 75. That was a hell of a development. Suddenly, this acceleration of innovation happened, and the supply chain did not still follow. So then one of the worst business decisions ever made in the 20th century was made, something that up to now your teachers haven't spoken to you about, the bad example of not what to do. Well, what the leaders of the electronic industry said, well, I guess if it takes 6 months to do anything, we need to forecast what we're going to need in 6 months' time. That's the dumbest business decision made in the 20th century. I'm going to speak to you about that business decision. It's an interesting one. Of course, it makes no sense because in an innovative industry, how can you forecast 6 months ahead of time what you're going to need in 6 months? Crazy. And things happen which are kind of fun, okay? Just to give you a small example. The first forecast the industry got from Apple about how many iPods they were going to sell for the first 12 months turned out to be 1 divided by 40, the actual amount of iPods that were sold in the first year. So imagine the scramble. Imagine all the promises kept, the promises not kept. That's one side. I don't want to speak too much about the other side, except to quote one famous number, which was in the first page of USA Today about a year ago. I hope you noticed, you who are in the operations track of this wonderful organization here. There was a company, which is a reasonably famous company, which was the glamorous company of 5 years ago, Cisco. I guess you've heard the name. They wrote off, listen to this, they wrote off $2.1 billion of inventory. That's the price of that unbelievable mistake to try to forecast in an innovative industry. $2.1 billion of stuff thrown down the chute in the crusher. Even for Cisco, that's no small money. By the way, nobody got ever fired about that. Unbelievable, huh? I guess it's considered the cost of doing business. $2.1 billion of bottom line was written off. This is our industry. This is the state of imbalance of our industry. It creates missed sales during growth time, not much because everybody's late. It creates huge write-offs during slowdown, as was experienced in 2001 by the high-tech industry. That's why I'm with Solectron. I'm going to change this. I'm going to resolve this imbalance. That's the vision we have in Solectron. So let me try to explain how the heck am I going to do that? Well, first, in order to do that, you've got to think your business and totally operate differently. You can't just do the same thing. If you continue doing the same thing, you're going to get the $2.1 billion again. Or in my case, I'm lucky because, they say in the books in university, if you want to change and transform, you've got to create a crisis. Or in my case, I had nothing to create. Let me introduce you to the perfect business storm. All right, Solectron. Solectron is a company which was a very exciting company. And 15 years ago or 10 years ago here in university, perhaps, they would have made the list of the top 2 pick. It was a great company which was created in the 80s because some people began to realize that this little problem I was describing was a real issue. And so you know what good businessmen do when they have a real issue? They try to get rid of it. That's most 80% of business people do this. Don't ask me to resolve it. Just let's find somebody else to resolve it for me. So that's the beginning of outsourcing in the electronic industry. Let's get rid of the supply chain. By the way, if you read some declaration of the Cisco CEO at the time, he would have explained to you in the mid-90s that he had invented the ultimate flexible supply chain. He had none. Well, it was not so flexible. He got $2.1 billion of tsunami. So who was that supply chain that created? People like us. That's how Solectron was created. We are a pioneer of this industry called electronic manufacturing services. We make for other people. We were dumb enough to come and say, you know, we're going to resolve this problem. We had no idea how to resolve it. It's called contract manufacturing. That means you pay lawyers to try to push the problem back to each other. We did that pretty well at the beginning, and as it was growth only, the company did very well, because that major issue, that tsunami here coming your way, only comes when it slows down. So we did very well, we grew, and then the crisis came. The famous crisis, and in our case, we even did many worse things at the end, when the growth, you know, remember at the end of the 90s, everybody in the Silicon Valley knew how to make gold out of lead, I guess. Yeah? We are the ultimate alchemist of business. And we did many, many mistakes, including buying a lot of companies, the merger and acquisition craze. We wrote off, look at this, $4.4 billion. $4 billion of goodwill, $400 million of inventory. So I guess we paid lawyers to try to pass inventory to Cisco relatively well, given what happened to Cisco, but we kept about half of it. At the end, you know, this kind of thing always is about, you know, 50-50 type of deal. Nothing has changed. So we went in a total blow-up, an implosion. You can see some numbers here, 3 years of losses, 16 quarters exactly. We closed 123 plants, we restructured 62,000 jobs, and we lost about $24 billion of market capitalization for our shareholders. The stock went from about $40 to $1. That's the crisis. So you see, I had the perfect storm. I guess that people would not say, if we continue to do the same, it would be a good idea. I found very few people in the company saying that. Some of them would try, but they don't say it. So then we had a new management coming. The board finally awoke and fired the whole management and got a bunch of troopers, including me, who said, we know how to resolve this. And we have a new management team. And honestly, we also have, and something that you have to be very, very, you know, all these things happen, it's not the people's mistake. We have unbelievable people. Just by the nature of who we are, right? People who want to do manufacturing, they're either crazy or very nice. I think they're both. Right? And we have some unbelievably dedicated people to our customers. They were ready for change. So in a way, my job of coming with a new idea is easy because people expect that. You know, when people are halfway down the cliff, they're going to believe you, whatever you tell them, because they've got nothing to lose. Right? And that was the perfect storm to make the change possible in our case. So we're building the change on 3 things, which we have called, you know, modestly, the Solectron production system. 3 major pillars that I want to speak to you about today. The pillar of lean, also known and should be known as the Toyota production system, which the word lean was invented by Professor Jones, MIT professor who went to Japan in the late 70s on a sabbatical where the MIT said, go and study Japan, why are they eating our lunch? And he came back and he said, no, it's good news. Japan is as screwed up as America, except one company who has something very special called the Toyota production system. And he coined the word lean production. There are many words. In fact, the English word is perhaps the least nice word about this discipline. The Spanish word is very nice. It's manufactura esvelta. The French word is kind of nice too. It's chasse au gaspille, which is to hunt waste. And there is many words across the world. Of course, there's Japanese words. So lean is one of the foundations of our transformation. I'm going to come to what is that. Six Sigma quality is the other foundation. And then the one in the middle here, which is change management. That's the one I learned from my former boss that Ilkar quoted, Jack Welch, who is the world leader and a world champion of change management, of getting people rally around an idea, of moving an enormous company with incredible diversity around 2 or 3 simple ideas, rallying the energy and leading people. So change management is what I learned the hard way sometimes from Jack, but the good way also some other days. So this is the roadmap to success. So lean, the 5 cornerstones of lean at Solectron. The first thing is you've got to define value. And it's very easy to define value. You go with a customer to your plant or to the place where you produce whatever you're producing for that customer, be it a service or a product, and you show him what you're doing. You don't do presentation. You take him to the shop floor and you show him what you're doing. And then you say, would you pay for that? If he says yes, it's value. If he says no, I mean, you got all this bloody inventory sitting around, I guess that's your problem, not mine. What are you doing there? Reworking something? Well, I guess I paid you to do it well the first time, not the second or the third time. So the rework, if you don't mind, I don't pay for it, etc., etc. This is an interesting way to open your eyes. Because 1 minus value is what the Japanese call muda, or waste. And that's what lean is all about. Chase what is not value for the customer. Okay, the second thing you do is you do a value chain map, which means now that you've understood what value is, you go and walk your process and you do a process map with 2 small differences. So in the course of process map that you took here, I want you to add 2 small ideas. The first one is map what happens, not what's supposed to happen, which means you go and do your mapping on the shop floor. Whatever is shop floor. If it's manufacturing, it's in the factory. If it's in an office somewhere, you go and map what's going on. Map what's going on. That's a huge deal, because what's really going on out there is never, listen to me, never what you manager thinks is going on and what they are telling you is going on. This is the surprise of the life when you go and do that. And then the second thing is, so now you're process mapping what's really going on. And then as you map every step, you say, is this a value add step or is this a waste step? And you just do that. And then once you've done that, and I'll come back to the result of that, then you begin to eliminate the wasted step. And there is some very simple thing. The most hurtful of all wasted steps is to make something that nobody wants. That's the ultimate insult to humanity, I guess. Because you use capital, you use natural resources, you use people, you make something, and you send it to the crusher. $2.1 billion in the case of my example. Unbelievable. And there is a way not to do that. It's called pull. Only make what the customer wants. Not what some forecasts say, not some statistical guru say. You make what the customer wants, when he wants it. Now, that means starting production only when we have the final demand of the consumer. Whoa.
So how did that relate to services?
In case of services, the accumulation of waste and overproduction in services could be that you have too many people already. Okay, so you have people waiting. It could be that you produce, for example, bank records and all sorts of papers that people really never read, right? So you can define that too in services. It's of course easier to define in manufacturing, and I'm going to center the pitch here around manufacturing. I absolutely would like to say at the beginning that what I'm saying is also true for services. In fact, I did some work like that with GE Capital, It's more complicated in services because you don't see the waste so well. Okay? So, of course, once I've said that, then the next thing is, well, you need to flow. Because now if you have decided that you're only going to make what the customer wants when he wants it, you better be fast. Right? Because the customer is not going to wait 6 months. And so the next thing is removing the other major source of waste, which is bloated inventory and waiting, by ensuring that goods flow, or services, continuously through the supply chain and never stop. And then finally, and perhaps the most difficult concept for Western brain to get used to, is the concept of Kaizen. You see, the idea here is that, so now we know that there is waste. We do a value map and we find some waste. I'm going to tell you how much a little later. So what we want is eliminate it. Yes, and that's what we want. But elimination of waste, of total waste, is a state of perfection. And you can only grow towards it. You can only progress towards it. You progress through very small, very focused steps called Kaizen. In fact, the real word in Japanese is Gemba Kaizen, which means continuous improvement on the shop floor. Remember the shop floor. Where it happens, not in an office, down on the line or down in the office where you produce the service for the customer. And that's what you do, a succession of small but very action-oriented events within the production process. This is it. You know Lean. Now it's just a question of doing it. Now, why is this such a big idea? I want to speak to you about this chart. The first time I did a value map of what I was doing in General Electric company, so I was the head of supply chain operations for GE Medical Systems, one of the most prestigious, if not the most prestigious, division of, at the time, the so-called, if you believe the newspaper, best-run company in the world. So I sent my people, when I learned a little about this, to say, let's do that value chain. That's kind of value mapping. It's going to be interesting. They come back to my office 2 weeks later, really good people. And they tell me, Marc, we found 90% of waste. I kicked them out of my office. I did my French stuff, you know, like Ilkar knows how to do, you know, right? And I just kicked them out of my office. I said, you guys, you're crazy. Go do your work properly. So they came back a week later. They say, yeah, you were right, boss. 92.8% waste. Oh, my God. So I went through 3 feelings. First, shame. I was in charge of that stuff. For more than 2 years, I couldn't accuse my predecessor anymore, which is usually something you do in business, I'm sure of it. So, of course, after shame, I went through fear. My boss at the time, Jack Welch, not world famous for patience with incompetent people. And I guess 92.8% of waste is a good definition of incompetency. Right? I went to sleep. I use my Carnegie Mellon training, you know, be positive. They teach me here, you know, anything is possible. And so the next morning I awoke and I said, well, I guess after all, it's not so bad news. Jack wants 10% productivity every year. I got 9 years of peace. So the point is that a traditional thinking company doesn't know about the waste and keeps on optimizing the 5-10% of real value add. A lean thinking company addresses that incredible opportunity we all have, which is the 90% of waste. And there is no shame at having 90% of waste. It's the normal company ratio in the Western world, most companies in the world. A few companies in Japan have a different ratio, especially one called the Toyota Motor Company, because they've been at it, at eliminating waste since 1946. And they're still doing Kaizen. So how do you address that waste? Well, that's when you go into the real fundamental of Lean. And I'm not going to give you a Lean course here, because there is all sorts of interesting words that you see here, like Ejunka, Jidoka, just in time. And I'm just going to give you a few examples of what we have done. But I do have a few readings for the students at least, not the alumni. But for the students at the end of this talk, that I really recommend that you go and read that because there is a lot to know about this. So there is a lot of ideas. They're all very simple ideas. Okay, we use words in our lean world like choo-choo train, like doctor and nurse, like supermarket. So we have got all sorts of strange things, which are all very simple. They're just around eliminating waste. We do spaghetti charts. It's not an Italian dish. It's a value map of how our workers on the line walk every week. Because of course, if you show to a customer a guy who's walking all over the place to look for a part, the customer is going to say, no, I'm sorry, I don't pay for marathon runner. I pay for electronics. And we have marathon runners. We employ workers on the line who walk more than 5 miles a week. Some up to 10 miles. It's totally crazy. So we do a spaghetti chart of what they do. And then, of course, you get this unbelievable thing. And then you say, well, why don't we attack that and reorganize everything in the factory like that the worker on the line doesn't have to go and run around the place. It's a pretty good idea. See, it's how simple. So I'm going to, and then there is this middle pillar is Six Sigma, because, of course, one of the worst waste is bad quality. Right? And I'm going to come more in detail on how you address quality as, total quality as one of the absolute driver of what's going on here. So let me show you a little how we've deployed Solectron production system internally since June 2003. This is my Gamba. I have PCBA operation, printed circuit board assembly. I put component on boards, right? So machines and hands and all sorts of things going on. I do system assembly and enclosure, which means I take those boards and put them into metallic boxes with all sorts of cables and things and power units, and then I switch it on and test them. Right? That's the computers or the telecommunication center, whatever, the fire alarm here. Right? I do this kind of stuff. So, and then I repair also boards and other electronic systems. And of course, I've got all sorts of warehouses. So now you begin and you say, okay, let's go. Let's value map what I have there and address it. Here is what happens. First thing we did, we closed all the outside warehouses. One of the tendencies of waste is to be hidden. So when you work in manufacturing later, an advice, never have an outside warehouse. Forbidden. Okay? It's got to be in front of our eyes. All that muda there, you see on the left? All this ugly stuff. 6 months later, you see on the right. What you see on the right, Ilkara would be very proud of me here. You see Ilkara was still playing soccer inside my empty warehouse. That's the guys know that I'm a soccer fan, and so they organized a little soccer game for me, and so you can shoot a goal, right? And I'm still bad at Ilkara. And in the middle of the thing. But we decided we were not in the indoor soccer business, so we just sold the warehouse, right? So that's what we did. Here is what it did to the Solectron inventory turns in 2 years, 5.9 to 8.1. That's a lot of cash for Solectron. Back to pay the debts, etc. So then what you do is once you have the parts inside the plant, what you usually get at the beginning is this crap on the left here. Then you organize something called a supermarket, which is what you see on the right. You can see the parts. There's no boxes anymore. As you can see, there is a front of the supermarket, which is inclined this way, where you shop from that side. So you take this one, okay? Then the next one goes down, because it's slightly inclined like this. And obviously, you load from the other side. Oh, what a great idea. They do that in every supermarket in America. We don't know how to do that in manufacturing. That was invented by Ono-san, the Toyota guy, who is the father of the Toyota production system. When he came to America after the war, he never seen a supermarket in his life. He came back and he said, I know what to do in my warehouse. And everybody goes shopping. So we have shoppers, we have carts. We have, you do your shopping normally, right? Because you can see what you're shopping for. So this is, we measure, of course, the number of parts in supermarket. You see I'm not yet there, 50%. of where I want to be, but we've progressed a lot from practically nothing 2 years ago. Look what happened to the pickup time. Oh my God. Remember the waste? I guess the customer is not paying for my guy searching for something in that mess. Half. Now, you know how many parts I pick a day? 2 million. All over this electron. I have 60 plants, 58,000 people, 8,000 people in warehouses. Just make the calculation. Just calculate now, back in dollars, what this means. Okay, because I'm now really saving something. It really only takes 23 seconds to pick apart. When you're a lean manager, you save cost. You don't cut cost. Cutting cost is the easiest thing to do. Fire a few warehouse guys. Total bullshit. What you've got to do is do this. Help them to do a pickup of the part in 20 seconds rather than 45. Now you can save cost. So we do that all over the world.
50% now, what's your target? What's realistic, do you think?
To pick up a part?
Overall parts in stock in supermarket.
85%. There's a few parts that are very slow moving or very big. But in my business, 85%. By the way, go to a Toyota plant. They're about at 98. They have no parts in big warehouses. None. Even the tires and wheels. Okay? There's 250. Takt time is 1 minute per car. That's 50 cars. And then the little truck comes with the next 250. So this is, this is something that we're doing. You see, it's very simple. Just do the simple thing, right? And you can absolutely transform the way you work. Of course, you need all your people to believe in this and do it with you, because you can't do it alone, right? So I got 5,000 people doing this right now, reorganizing the warehouse. One other advice. If ever somebody ever sells you a computer system which knows where the part is, please don't buy it. Computer system never knows where the part is. People know where the part is. The worst thing in the world is optimized warehouse by computer systems. You never find what you're supposed to look for. You know why? Because data input is at best 3 sigma. When you do 2 million picks a day, just do a little calculation. Okay, 3 sigma is like 94%, right? So at 2 million times 94%, you're left with 1 chance out of 1 million to find something. That's a huge deal. Because it poke-yokes, and I'm going to come to that concept of foolproofing where the part is with the people, and they can find it. And of course, where the computer knows where the part is. So then the next thing is a few other things you learn. Okay, here is the plant on the left. That's a SMT line, a surface mount technology line. When we began, you see there is all sorts of very interesting work in process here. This stuff there. The boards here, half finished or whatever, right? That's the plant, same plant, 2 months later. So what did we do? Well, we did one big thing, which is that thing here, the changeovers. Why the heck do we make work in process inventory? Well, for one thing very simple called changeover time, right? So, it takes time to change the machine from the previous board to the next board, whatever you're making, in this case, electronic boards. Just assume that it takes you 2 hours. In the case of electronics, it took us about 1 hour and 50 minutes when I came on board. I guess if you do 4 changeover a day, a shift, you do nothing, right? So same kind of reasoning that we saw with the forecasting. So given that it's slow, I have to forecast. So people say, well, given that it's slow, I have to make large lots. Okay, I can't make 10 boards. I got to make 1,000 boards and then change. Yeah, but what about if the customer, needs 100 boards a month? I guess you've made the next 10 months. And if his demand change in between, you're done. You're going to tell him your cycle time is 10 months. And you create all these works in process and all these things you made. ahead of time. Well, what's the breakthrough? Are you sure you need an hour and a half? Is the question. And you do what Toyota calls SMED, single minute exchange of die, because it was invented for the forge. And you change your machine in a single minute. Now, in our case, we began, as you can see, at more than 60 minutes. It was an hour and 50 minutes at the very beginning. We are at 14, in fact at 12, I just got the new report. And my best plant in the world is at 4 minutes. And our Japanese masters tell us 99 seconds. So we still have some distance to go, but we're getting there. Just do the little calculation. You understand that if it takes 14 minutes to change over, well, I guess I can change over 10 times a day, and I still have a lot of production time. And you know what? We did this with no investments. You don't have to have a big machine. You just have to put the people brain on it. And when you put the people brain on this, the stuff which happens is beyond your wildest dream. So the way we put the people brain on it was we spoke about Formula One, or NASCAR for American friends, but I'm going to use Formula One because I don't follow NASCAR that well, I apologize. But Formula One, I guess most of you have heard about a guy called Michael Schumacher or Fernando Alonso. So let's take Michael. So Michael is fighting out there, with his red Ferrari for every tenth of a second. He arrives in front of the pit, he stops to change the tires, put some gas, right? They go like crazy, right? So here's what used to happen in a Selectron pit stop. As Michael is doing this, some guy would come out of the pit and say, "Hola, Michael, take your time. I think we have a flat tire here." And he would show up with a foot pump. Imagine poor Michael trying to fight for tenths of a second out there. That's the way we used to change our lines. Now we do it like Michael Crow. Every work that has to be done before is ready. It's like a Formula One pit stop. Of course, the tire has the right pressure. Right? So for us, it's different from tires and wheels, but it's the same principle. So we've explained that to our people, and we say, go use your brain. And the things they're doing is just out of this world. Out of this world. Right? So every month I give the checkered flight premium to my team who has done the fastest changeover during the month, which is at 4 minutes this month. And that's the time between the last good board and the first good board. So no crummy work. No sending Michael with bad tires and bad gasoline. No half finishing the filling up the tank in order to send him fast out there and then he runs out of gas. So you absolutely get the people brain beyond this. Just one example. Right? We do, in this machine, you have feeders, which are kind of like forks, which contain the components that you place. Well, some guy one day came up and say, and we place them one by one. He designed in a moonshine shop. We have moonshine shops. We have all sorts of very strange stuff you do. People do their own little things. And he designed kind of a handle grabber. And now he puts 5 feeders at one time, rather than one. A few seconds gain. It's all about seconds. There is no big deal there. But imagine the difference it makes on a factory for the customers in terms of speed and for us in terms of inventory. Like $180 million of inventory there on just WIP on that part of the plants. We reduced WIP by $250 million in the whole company. So, there are some other things, and I don't want to go into too much detail here, but this is how, a regular plant looks like, with long lines and people, waiting, etc. This is what we have now. It's called U-cells. Okay? People passing the thing to each other, one-piece flow, unbelievable stuff. I don't want to go too much in detail here, but that's the ultimate, okay? And that's the way when you visit a plant, you immediately know. And if you look at the way Toyota plants are, you'll see a lot of those. Look what that gives. I got 2 free factories out of this in terms of space utilization. It's pretty cool. $20 million a factory, that's $40 million of investment saved. So, the last one I want to really cover with you is the quality one, of course, the most difficult of all. The famous concept of zero defect, being a reality, not just a propaganda, being something you really go towards. Well, you use two things. You use Six Sigma and you use Lean. And the two you need. Now let me just, I'll come back to that chart, but let me, people speak to me, well, is it two war of religions here? How can you be Lean and Six Sigma at the same time? Well, because they're really complementary. Here is the everything you need to know about Lean and Six Sigma in terms of quality. You see, most of the things that you can see, you can fix with the fundamental tools of quality that exist in Toyota production system. For the stuff that you cannot see but only measure, i.e. which is complex process or complex interaction in systems, etc., then you need the Six Sigma discipline with the statistical discipline of Six Sigma. This is the reactive part of Six Sigma called DMAIC. There is also a proactive part of Six Sigma called DFSS, Design for Six Sigma. But you begin, of course, by the reactive part. And so here is how you combine both. You see, when you can see a defect, you can fix it with Lean techniques, and I'm going to speak of those. When you can't see a defect, and you have to really do a lot of analysis, then you use Six Sigma technique. So really, Six Sigma is a part of Lean in the sense that the elimination of waste is the overriding concept. So here is the kind of stuff you do in Lean. You do what's called poka-yokes. You eliminate human errors. That's a Japanese word pronounced with a French accent, so of course, even the Japanese people around here don't understand what I'm saying. But it means foolproof. You can write full F-U-L-L or F-O-O-L. And foolproofing is the only way you transform human beings in Six Sigma machine. You see, all human beings are Three Sigma machine. In anything we do, we're going to do about 6% of defects. Now, you could argue, rightly so, that the Japanese are more like 3.1 Sigma machine, and the French, who are at the bottom of the pile, are more like 2.9 Sigma machine. But we're all about the same, whatever is our culture, etc. The stuff about the Japanese being so much better, that's why they can do quality and we can't, just total crap. They're just marginally better. So what do you do? How do you do a Six Sigma product with a Three Sigma machine? I guess you can't, mathematically. Except if you can transform this machine from a Three Sigma machine to a Six Sigma machine. How do you do that? Let me take an example. In my family, I have a Two Sigma machine. That's my daughter. She can break anything. She's known in the family as Miss Catastrophe. She's the ultimate Haas test for any electronics. Well, she has never managed to plug her computer the wrong way around in a socket in the wall. If she could, she would. But she can't. Because an engineer invented a socket which makes that you can't plug the live in the neutral and reciprocally. It's a poka-yoke. It transformed even my daughter in a Six Sigma plugging machine. That's what you do with every one of your workers on the line with Lean. Unbelievable. That's the difference between a Toyota car and a GM car. Toyota has a penetration of poka-yokes on their line of somewhere around 90% of every human gestures performed. That's a hell of a difference. That's what we're doing. So here is a few poka-yokes we're doing. Okay? Let me speak about this one in the middle. It's the most fun one. This is called the doctor and nurse poka-yoke. You know, when you make product for the customer, the person who makes a product, that's the doctor. Because it's got to be done fast, and it's going to be high quality. So what you do doctor and nurse. The person who works on the line is the doctor, and the nurse is going to prepare the tools for the doctor, or the parts in that case. You see that little tray up there? That picture above there? That's kind of a negative of the board. It's a thermoform plastic where the hand-placed component, this is a board where we're going to have to place some hand-placed components because you can't place it with a machine. They're all being prepared for the doctor. They will be exactly the right component, because if you try to put another component, it doesn't fit in that little tray. The polarity will be right, because if you put it the wrong way around, it doesn't fit. And of course, it will be positioned in front of the doctor perfectly, and therefore the doctor will position very fast all the components on the board. We went on hand-placed component from about 80,000 DPM to 0. We never place a component wrongly anymore. That's a hell of a difference. And it's one of my guys who invented that tray. We made the machine for $400 in the moonshine shop. And every time we have an engineering change, we change the tray. It takes us 10 minutes. You see how simple it is. Imagine the power of what I'm describing to you in every gesture you perform in a plant. You change the world in terms of quality. You totally change the world. By the way, what you do is you eliminate what Six Sigma calls the special cause. You know, when you do a Six Sigma project, you got a problem sometimes because some interference comes. You do your DOE, design of experiment, I'm sure you've studied that, most of you, and some kind of weird parasite comes in, which Six Sigma call special cause. Well, you know what? In a plant, there is a lot of special cause. They're called people. I got 58,000 of those special causes. And they perform about 500 gestures a day. So imagine how many special causes I have. So with Pokyokes, you eliminate the special cause. Now, if you have a defect, it really comes from the process engineering that you're dealing with, the temperature of the shouldering, etc. And now you can have the full power of Six Sigma. So those two disciplines are totally complementary. And they give results like this. Still not good, but this is the electronic industry, the crummiest industry in the world in terms of quality. You know, you have a PC, all of you, right? So we reduced the total DPM of the company, you know, that's a huge number to move, right? By 20%. Look, we reduced that one I'm very proud of. This is the return from the customer by 75%. We reduced the bone pile. Oh yes, you've got to know that when you work in industry, we all have this politically correct word to hide our sins. That's our rework, rubbish pile. We reduced that one by 62%. So you begin to move the needle seriously, right? So that's what quality is all about, combining the two most powerful quality disciplines in the world. Now, the secret of all this is not all these tools I'm telling you. It's the people. It's those people out there who do this every week. Every week. So I do about 5,000 Kaizen events per year in Solectron with people like those. You see, this is a Kaizen team from my California plant. You've got people in there, you've got engineers. We all have the same clothes, which is nice. Right? So you can't recognize engineers from their clothes. So we have engineers. We have, of course, first shop floor people who know what's really going on. And then we have a few candidates, such as HR guys or finance guys or the worst candidates of all, you know, senior management guys who come and do Kaizen events. And then we try to fix something very precise, very well defined, that we have a week to fix. And we do tri-storming, not brainstorming. We do things. We move machines. We conceive little tricks like the one you saw before. We do all sorts of fascinating things. Every week, everywhere. That's how you move the needle. So people power. That's really the secret. On the shop floor. On the shop floor. Okay? You close every conference room that exists in the plant, just off limits. On the shop floor, where it happens, with your eyes, and then you improve. The shop floor can be defined in very large terms. Again, I'm taking you the example of manufacturing. That's the easiest place to begin, because the problem of the other shop floor, such as office shop floor, is the waste is usually much more hidden. It's like, you know, in weight lines, in computers, and all sorts of very, very discrete places. So once you begin to move your own factory, then it's the time to expand to your supplier and to your customers. Of course, you can't do that at the beginning. I mean, because they're going to laugh at your face, right? You're going to come and teach them to do something you haven't done to yourself. But once you begin to see some result like the one I showed, then it's the time to expand. And this is, of course, for us, absolutely essential. Just to give you an idea, out of the cost, if $100 of price to my customer, there is a little margin for me, not much, but there is about 20, which is my value add, 15 to 20, and the 80 to 85 is material. So of course, I can't change the world if I don't change the rest of the supply chain, i.e. the suppliers. So that's where we're beginning. Now, that's also a very interesting thing. I want to speak to you a little about suppliers. I guess you've heard about this approach. This is the one which you taught in every purchasing class. This is the Lopezite approach. You take the customer, then you take the supplier, and you look at, I guess he's got, some cost and a margin. And what you do is you spend all your purchasing time in negotiating like crazy, i.e. squeezing his margin, and you're very happy and you've done a good purchasing job. Well, there is kind of a limit to this one. There's one limit which became very public last Friday a week time with Delphi and GM. GM squeezed Delphi to death. Well done, GM. What a shame. So that's one way to deal with your suppliers. The result of that way, by the way, is that for a car which costs $20,000, about $12,000 material in it. It was in USA Today, so again, a public number. Toyota pays $2,000 less than GM. And I guess GM has done the best they could. They bankrupted the suppliers. So what did Toyota do? Because, by the way, Denso is not at all bankrupt. It's a very profitable company. It's the Delphi of Toyota, Nippon Denso. And by the way, even Delphi makes money selling to Toyota and Honda. Why? I'll come back to that. Then the other thing you do when you want to reduce cost, what about sending everything to China? That's a great idea, isn't it? Let's transform, United States and Western Europe and Japan in museum, right? So, yeah, I guess it's obvious you're forced to. Let's take a little piece of electronics, takes 100 hours to make, $20 an hour, $2,000, right? Take the same piece of electronics, make in China, 100 hours of work, $2 an hour. That's well paid, okay? Clean, very nice people, not mistreated people. This is not slave labor. That's $200. You add another supply chain cost of $200 to bring the product back to the market. By the way, the first calculation is 20, but in fact it's 200 because there is a lot of cost associated with return, etc. That's $400. You don't need a PhD, even from Carnegie Mellon, to decide you send everything to China. That's the way people deal with cost today. Is the labor arbitrage the only way to reduce cost? Let's go back to this pie that we spoke about at the beginning. So this pie, as I said, is clearly, in the case of Electron, we buy about $10 billion of stuff. So this pie is about 90% cost and 5% margin at best. I mean, in our industry, very few people make money. Let's look a little more what's in there, in those costs. Well, there is 20-30% of commodity materials, silicone, I guess, or sand, right? Okay, fine. Right? This one, perhaps, there's not much you can do about, right? But the rest is all labor, overhead, and capital work for the people. Now, remember what I told you. Guess what? In this share of the pie, there is 90% of waste. So this is the way you have to look at the cost challenge. And now, instead of paying your purchasing people to squeeze the hell out of the suppliers, why don't you pay them to help the supplier reduce its waste? What an interesting idea. You go and see a Toyota purchasing manager, and you tell him, how can you work with Denso for 50 years? You're crazy, they're going to screw you. His reply is, I know everything. I beg your pardon, what do you mean? I know every cost of my supplier. And I work with him every day to reduce those costs. That is the secret. That is the reason why Delphi is bankrupt, why GM will be bankrupt. If they don't change their ways, I think it's hopeless. Because they haven't done that. They've never done that. Because that's hard work. That's not the easy triumph of going back to the great negotiation and saying, you know, I squeezed the supplier. This is years of work. This is what Toyota does with their suppliers. That's the real nature of a keiretsu. By the way, look at this little thing that happens on my famous other cost reduction. Well, the trick is that the famous 100 hours of work, remember, 90% of waste in it. So in fact, you only need 10 hours to do that electronic part I was speaking about. Let's redo the calculation. 10 hours by 20 is $200. 10 hours in China too, huh? Very smart people, they do exactly the same. In fact, my plants are in China, they do it. 10 hours, $2, that's $20, plus 200 logistic costs, $220. I guess nothing goes to China anymore. Of course, life is not that simple, and you understand there is a model behind this, but it means that there is some stuff that we need to make next to the market. By the way, China is also a market, and India, wonderful places to make things too. I'm not saying nothing goes to China, of course not. I'm saying you got to think about this. It's a crime to pay people $25 an hour to waste their time. That's the crime. The crime is not to pay people $25 an hour. The crime is not to pay the retirement and the benefits of these people. The crime is management who doesn't employ these people well. That's the crime. That's the change. That's why I believe that what we're doing is not only good for Solectron, not only good for the electronic industry. I only think that it opens a new paradigm for manufacturing in the world. That's why for those of you who are not fortunate enough to be born in China or in India, there is still a chance you could do manufacturing in the United States or in France or in Japan. It's not dead. In fact, there is an article I'm going to advise you to read called the Nagoya Boom. It's an interesting article. We'll come back to that. That's it. Now we know what to do. Okay, so now we're going to do all the way from the end consumer all the way to our customer, the OEM, to us, the Solectron system plant on pool, all the way to my sub-assembly plants, all the way to the supplier, with a few well-positioned inventory at the point where you have takt time differences. I don't go into it, because you do need inventory in some cases. And this is what we're going to do, put the whole industry on pool. This is the famous solution. This is the vision. This is how we're going to rebalance this famous imbalance. You know what? It was so easy. The solution to the problem was, of course, not to slow down innovation. Fortunately, nobody can do that anyway if they tried. And by the way, it's fantastic. It's what makes our industry. The solution was not to forecast. The solution was to accelerate the supply chain. And with 10% of value and 90% of waste, I guess there is a chance. Remember, it took us 6 months to do things. Well, what's 10% of 6 months? 2.4 weeks. I guess that if we can do anything in 2.4 weeks, we have a chance to be on pool on the customer. I mean, okay, it's 2.4 weeks, not perfect, but it changes the world. Because 2.4 weeks ahead of time, Apple began to have a vague idea of how many iPods they would sell. That's the game. That's the vision. That's our vision in Solectron to become the Toyota of the electronic industry, very modestly compared to Toyota, but just to introduce excellence in supply chain to the most outstanding and fun industry in the world. That's what I'm about. That's what we're working very hard, 60,000 people in me, to try to do. It's a long road. It's tough.
How much cost did it save
I have, well, we turned the company around on the P&L, but on the P&L front, we moved the gross margin of the company from -3% to +6%. That's the gross margin. So for us, that's mostly cost saving. You can always argue all the details, but we're speaking of $900 million of cost save. Serious money. Serious money. So just to conclude, there is a few things you learn through these things I've learned in life, Lean and Six Sigma in change management. Raise the bar on your team. No money, no people, no space. Remember, we did all these transformations, nothing special. Just no more people, no space, no investment. Just take the people to do better. Raise the bar. Celebrate every win because the journey is tough. Because Kaizen is the most demanding thing in the world. That means that tomorrow morning, you got to do better than what you were doing today. Every day, every week, you do a Kaizen event. So that's tough because you can never relax. You can never stop. It's a journey. It's not a destination. So do celebrate the milestones in a journey. Do a little party, hug the people, do the things you have to do as a leader. And throw parties. Now, parties, you do it the cultural way. Of course, it's not the same party when you do it in Sweden or in Penang or in Bordeaux or in Milpitas. But party with the people who have done the work. Face the new challenge with self-confidence. That's the big deal about Kaizen. Of course, it becomes tougher every day. Of course, there is a new thing coming every day. A new process, a new demand from the customer, a new challenge. Yeah, but you know that what you've done, right? So you just turn back and build self-confidence. You turn back and you celebrate not to be complacent, but to build self-confidence. Remember, you're never good enough for your customers. When you're in the service business, there is no end. There is no end. They want more every day. You know why? Because you and I want more every day. It's our mistake. It's us, the customer. It's nobody else. Why is my customer asking me to put the price down? Why is my customer asking me more flexibility? Because that's what you want. That's what I want when I buy the product they sell. So that's the law of the game. And then remember that one. That one I learned from Jack. A continuously successful enterprise is perpetuated by a continuously unsatisfied leader. And Jack was the ultimate unsatisfied guy. So just to conclude, I have a few things here that I leave as we have questions like that. You can take notes. Those of you who thought that this thing was totally crazy, please forget about me. Those of you who think there is perhaps something for my life in there, here is a few things I would advise you look at. There is the ultimate website in terms of lean knowledge, which is www.lean.org, which is Jim Womack's. Jim came back, as I said, wrote a book after his MIT thing called The Machine Will Change the World. And then he wrote another book, Lean Thinking. And then he decided that he wanted to be more than a professor, he wanted to be a guru. So now he has an institute, the Lean Institute. And so that's his website up there. The next one is very interesting, is the Nagoya boom. Okay? This is an article from a Wall Street Journal guy who went to Japan and had a shock of his life because he went to a place called Nagoya, which is kind of like the Detroit of Japan, and he saw an economic boom in the Rust Belt for people who make cars and brakes and cranes, all the stupid stuff you're not supposed to make anymore. An interesting article about it works. When offshoring doesn't make sense, that's an interesting article written by two McKinsey guys with whom I worked, and they worked with many people, many other industries than me, which calculates and which speaks about that example I took to you about the lean and globalization. Right? And then one article amongst many, but this one is a good one, about the co-prosperity model. It's a Harvard Business School, Harvard Business Review article, building deep suppliers relationship, where they predict the bankruptcy of Belfi, and they explain the difference between the way Toyota and Honda treat their suppliers compared to GM and Ford. So just basic readings. But I remembered, when I was here, the teachers always give us something to read, so I said, I got to do it also, okay? Now that I'm finally on this side of the stage, right? So that's what I wanted to share with you. Okay, so let's have a discussion now. Sorry, I was a bit long. But...
How long did it take you to drive the supply chain lead time down from 6 months to 2 weeks?
I'm sorry, I couldn't hear you very well.
How long did it take you to drive the supply chain lead time down from 6 months to 2 weeks? Have you achieved it yet, or is that a goal?
You never achieve a perfect lean supply chain. As I explained, Toyota is at it since 1946. It's a journey. However, what you have to do is, of course, you have to establish a certain number of milestones that you want to reach, right? And give a time for that milestone. So that's now 2 years that we're transforming. We've reached some milestone in terms of, for example, in terms of the WIP reduction, in terms of the changeover, in terms of flexibility for our customers, in terms of transforming our P&L, transforming our balance sheet, moving our turns from 5 to 8. Now we have to go to the next milestones. So there is, next milestones which we're defining. And as I explained, my next big milestone is to begin to penetrate the supplier and the customers. And we're beginning to do some lean work with the customers. It's very exciting work.
When you formulate the manufacturing cells, when you make them accountable for the process, in addition to parties, do you incentivize them as well?
That's a good question. I do not believe in direct financial incentives on the shop floor or in anything, by the way. Okay, I have a big discussion with my sales leader about this, because you transform people into mercenaries. I believe in sharing in the win of everybody, and of course I believe in celebrating special wins. So we do prizes, world competitions, stuff like that. We don't do direct salary change or direct commission type of payment for the people in operations.
What was the impetus for your Kaizen team rather than just empowering your everyday workers on the line to submit Kaizen improvements? Why do you have a team focused on it?
Or because, that's a very good question. You do teamwork because the workers know what's happening, know what's stupid. They don't always know how to fix it. So that's why a team which is made of workers of the line, plus engineers, managers, and some other candidates, as I described, help you get the best energy and the best result. Because, for example, in some cases, we're going to have, to design a new fixture, and we've got engineers very good at that. And the worker will say, if only this could stay in place in front of me, right? Well, then it will go away every time, right? That I want to do something. So then the engineer says, oh yeah, I know how to do that, right? You see the creativity there. So that's what you need. You need to really put all the brains you have, not just the people on the line. But the one thing that I never want is a Kaizen event where there is no workers. You can be sure we're going to invent something totally useless. That's for sure. Right? But that's a forbidden thing.
I have a question. I'm an ex-GE guy, so I'm seeing lots of kind of overlap here. I was Six Sigma, CAPS for change management. The lean is worked out and demand flow technology together. The supplier stuff is the supplier productivity engineer group, depending on which business you're with. My question is, in the details, how is what you're doing in Electron different from the way the rest of corporate America is treating these initiatives? Because they may not be getting the same sort of outcome that you are. So there's got to be something a little different in the minutia that I see you doing. I'm going to push on that a little bit.
You're not going to make me say anything bad about my previous company.
They're great. I love them.
No, look, as usual, I mean, what I shared there is kind of like learnings, that you do over time. And GE and Jack's leadership was really dedicated to Six Sigma. In fact, I'm part of that team that was originally around Jack on this. So I know this really well. Right? I was the head of Six Sigma for GE Medical Systems. There is a limit. You see, you keep on. That was one of the great things of Jack. He kept on reinventing the company all the time, right? So, Six Sigma reaches a limit, right? When you get crowded by those special effects. That's what happened when I got the famous phone call that Ilkar was telling me, he was telling you, okay, his version was a nice version. The real version is a bit worse than that. But when I was promoted as head of operations for GE Medical Systems, so Jack has said, well done, go and tell your wife you're a great guy, tell her to buy what she wants, invite your friends, do a party, tell them you're made officer in the best run company in the world, brag about it, and then on Monday morning, here's what I want you to do, and if you don't deliver, I'll fire your ass. Right? So, thank you, Jack. It's nice. You give me 5 seconds to be pleasant, and then back to work. Right? He was the ultimate Kaizen guy. So Jack wanted me to fix the next thing, which was we didn't deliver our CT scanners and our MRI exactly how our customers wanted. We always had a problem. We're late, early, this kind of stuff. And I tried to fix that stuff with Six Sigma, and I could not, because there was always something else appearing. There was a new X because there is no vital fuse. You see, Six Sigma is a discipline which works if you can find vital fuse. And by the way, when you deal with scientific process, there is indeed vital fuse, right? I mean, it's a theory, but you always operate in a certain shape of the curve. Anything in science is a function. And in that shape of the curve, only a few, if y equal f of x1, x2, xn, only x2 and x8 are important around that shape of the curve, right? And that's what makes Six Sigma so powerful. The problem in operations is that there are so many x's that there is no end to it, that you never find it. And that's where the lean thing came. And GE began to do some lean. Took a while, and I was one of the promoters of that. So why do American management never does it completely? And why do the Japanese got it? I'll tell you that, please. Because it requires fortitude. Because it requires that you just do this and not the latest fade. Because it requires to take some incredibly difficult decision, like Jidoka, which is stop the line when you have a defect, which is another dimension of the Toyota quality system. Those things are so unnatural, and only a leader like Jack can break through. Jack was totally fanatic when we did Six Sigma, totally. The whole company followed. There is very few leaders in American industry as fanatic as Jack for improvement.
You talked about the value proposition, like making people understand the value of what we do. So what are the kind of techniques, or what do you actually do to make people convinced about these kind of initiatives? Because often that's the hardest thing to do, to make people convinced about the value of a Kaizen or the value of the Six Sigma. Like, I mean, what's the kind of, what's your approach on that?
Look, this is perhaps the easy thing to do with the people on the line. Because all that waste that we used to do, like making them walk all over the place or search for parts or repair things that they knew they were not doing well. Most people in every culture I know don't like that. And when you seriously tell them, we're really going after that, their first reply is, of course, yeah, I've been telling you for 25 years, you stupid managers, you never heard me, right? So I don't believe you, of course, at the beginning. And then you do a Kaizen event. And then, I go on the Kaizen floor for a week, or my direct reports go. They say, shit, what's going on here, right? And then when you begin to get 50,000 people to believe, wow, then things happen, right? So just do it, right? Just go do it. And it will work, because what you're doing by eliminating waste is what every normal human being in the world wants to do. So when you ask people to do what they want to do, it's kind of easy. So just do it. Real. No bullshit, no pretense, no presentations, no, doing it here in this classroom and not doing it every day of my life. Or for my managers. You can imagine that my guys are going to spend some time on the shop floor. Huh? They only do office stuff. I'm not going to be too happy. And it goes all the way down. It's organization the world way around. Okay, Toyota has a chart which shows that. Usually you see an organization and the CEO at the top and the workers at the bottom. Well, we do the other way around. Okay, everybody serves the line. Everybody works for the line. So when you stop the line, I'm doing Jidoka, which is stop the line on defect. Everybody's on the line to know what's going on and help.
John Sangenberger wants to take it over. Thank you very much.
Thank you.